Is this, yes, okay, it's recording. Okay, there's some more messages. Brianna messaged me personally. She said I was going to send my homework to you, or I was going to send my homework to my tutor, but they told me to send it to you. Brianna, who's your tutor? Anya. Anya is your tutor. I was going to send my homework. Okay, no, send it to Anya. I'll tell Anya that. Yes, the homework gets sent to your tutor. Yes, and here's the, okay, I'll send you the link. So people are asking for the link. There it is. Okay, great. Any other questions organizationally related? Let's see. I need to invite one more person to our meeting here. You can actually, you can see all my email. Okay, give me just a second, people. Please prepare. I mean, if you have any questions regarding homework from the past, or anything that we've covered, please ask away right now. Now is the time before we get started. Anything? Nothing.
Can I see the homework?
Can you see the homework? So if you click on the link that I just sent you, and you go to the homework.
I'm doing the right one because I was getting so confused with other classes, and I'm gonna make sure if I'm doing the right homework. That is.
It's the only homework that is available online right now.
Oh,
okay. Well, I want you to be comfortable. So here, can you see this?
Yes.
Okay, so I clicked here.
Mm-hmm.
It's this assignment.
Okay.
Distributive property, I think like linear equations and systems. So we're gonna kind of finish up the material that you need to complete this homework assignment today. So if things don't make sense, hopefully it'll make sense by the end of the day. Okay?
Yes.
Okay, great. So I think, great, there are 45 of us now, so that's a great number. Here's some of the feedback. Thanks everyone for your feedback on the course so far. Here are some of the things. I appreciate all the positive feedback. It means a lot. It's helpful to know that many of you are enjoying the lecture. Here are some of the kind of negative and constructive criticism things. So some people are overtaking the class, okay? I like it when people participate, and the only way, if you feel that a few people are getting their voices in, there's nothing you can do but chime in yourself. So if you're tired of hearing the same voices, then start participating, okay? Could there be written notes / tips that we could write down? I really don't know. I'm recording all these lectures so you can watch them all again. They're gonna be on YouTube. I'll send a link at some point. I don't want you to rely on the recorded lectures. I want you to be here and interact with me. So the lectures are being recorded, and do take notes of everything that is being covered. I mean, this is very much like a class, okay? We're deriving things, we're coming out with results. So write down the important parts, write down some of the examples. Today we're gonna do a ton of examples. Sorry, I'm distracted here. Yes, please take notes on your own. Someone thought it was moving too fast, maybe slow down. And at the same time, someone else said it's basic review. So it's a little slow. So given that there was sort of an equal number of these types of comments, I think I'll keep the pace about the same. I know some people are gonna be very bored and some people are gonna be a bit behind, okay? So that's just the way it'll go. I can't make everyone happy, but I'll try to throw in little asides, okay, that makes the juniors and seniors especially kind of interested, and I'll also kind of spend some time to review, okay? Sometimes you get distracted and talk about another topic. Okay, that was helpful for me to know, because I realized that you can't see this chat. So whenever I like sort of abruptly stop talking and I start reading something from the chat, it's because I've clicked on the chat. Okay, so I'm reading your messages, okay? I'll try to read the chat messages as I answer the questions, okay? So this is a question from the homework. Who has done this? Who is me?
Mm.
Let's see. There was a better way that this worked where I could see who's talking. Okay, whoever said me, how do we kind of go about this?
So factor out x cubed.
You factor out x cubed, great. Okay, great. So we'll talk about sort of the mathematical meaning behind some of it. Okay, and then what's left?
X squared.
X squared. And anyone, you can chime in.
X squared minus x minus 2x.
Great. Minus 2x or just 2?
Just 2, yeah.
Yes, and this equals 0. Okay, great. So we're going to talk much more about higher degree polynomials later in the course. This is really an exercise of distributing and factoring. So we talked yesterday about how distributing is the opposite of factoring. Okay, and what are we doing here? Distributing or factoring, going from here to here?
Factoring.
Yes, very good. So the way to always check your factoring, you should never get a factoring problem wrong because there's a pathway between what you're given and where you're going. So if I wanted to check if this is right, I would just distribute, right?
I have one question.
Go ahead.
So for this one, it says find at least one solution. So can you just say x cubed is equal to 0? It counts as one solution.
You're saying that this is a solution?
Yeah.
Who agrees?
That's not a solution, I think.
Yes, and sorry, who's talking? I wish I could see your.
Oh, it's me, Larissa.
Okay, Marissa, thanks. Yesterday I could see like who was. I could see your name. I don't know what the deal is with Zoom. I've been having. Sorry, this is. Okay, we'll just deal with it. I might not be able to address you by your name. Okay, so Monica suggested that x equals 0. So Monica kind of gave me all the solutions, but let's get to Monica. You're right, but okay. So Marissa, why is this not a solution? Why by the way it's written right now, is that a solution?
The x cubed, yes, it's right, but the solution should be 2, not 0.
The solution should be 2. Well, so you know when we have like a line in the form y is mx plus b, what is the solution to this? The solution means the x-intercept, right? What is the x-intercept? We've done this. We spent all day on this.
Negative b over m.
Yes, good. So look, when you write the solution, it has to be explicitly in terms of x. In other words, it has to be like x to the power of 1. What is the power here?
3.
Yeah, so we need to take the cubed root of both sides to get something that says x equals, right? You want to find x. You don't want to find like some cube of x or some other expression of x. Does that make sense? So this in itself is not this is like a correct statement.
Oh, no, that's basically what I was saying. Okay,
great. So x is the cubed root of 0, which is obviously 0, right? Because 0 is 0.
Yeah.
Okay, so for the freshmen and sophomores, this is all you need because this is all I expect you to be able to do at this point. We haven't talked about factoring quadratics and all that stuff. For the juniors and seniors, yes.
I learned it a different way. And
You
this
learned
is
it a
kind of
different way. Can
confusing
you
me.
explain?
Huh?
Can you explain what you learned? You said you learned it a different way. What does that mean?
A different method.
Okay, so can you summarize sort of? It's okay if you can't. I mean, there are several ways to do this problem. In fact, look, you know the easiest way to do this? Look, by inspection, the best way to do a math problem is what we say by inspection. So you literally look at the problem, you say, okay, let me guess a solution. Wouldn't x equals 0 work? Like if you just put in 0, if you just looked at this, you didn't do any of this junk. You just look, hey, let's let x equal 0. 0 to the 5th is 0. minus 0, that's 0. Minus 2x cubed, it's all 0. 0 is a solution, clearly. So you could say by inspection, x is 0. That works, that's fine. And
But the other two, don't you just take the x squared minus x minus 2 and then factor that out twice and then...
Yeah, so if you're a junior or senior, to find the other two solutions, then you would factor this. And this factors into this. Okay, so we're going to talk about this. We're going to talk about how to factor. I know this is kind of messy here. But so yeah, so if you're a junior and senior, I would expect you to give me these solutions. But if this doesn't make sense to you yet, that's okay, because we're gonna talk about how that works. Okay, does that make sense? So
Yes.
okay, great. Okay, so yesterday we talked a lot about lines. So occasionally I'll do this and I'll like kind of do a homework problem for you. So it's worth your time just to copy this down because I'm basically helping you with the homework. Okay, so I'll read some of these chat messages later because I think some of these are more personal questions. Okay, so yesterday we talked about parallel lines and what is true about parallel lines. Like, look.
Slopes are the same.
Yay. Nice.
No matter what the distance is, they're always not going to intersect.
Yes, very good. So this is sort of a geometrical, what you just said. I wish I could see your name. What you just, okay, great. This is so, I just wish I could, I don't know what is wrong with. Okay, anyway. Okay, sorry I can't see your name and sorry I can't address you by your name. But yes, so parallel lines don't intersect. Great. And so today we're going to talk about systems of linear equations. So these are two linear equations that collectively represent one statement. So say we have these two linear equations. And so this is a system, right? So this represents two lines. And what is true about the slope? What is the slope of this line?
1.
Yes, and what is the slope of this line?
1.
Yes, and so are they, how do they look? Are they parallel, perpendicular?
They're
Parallel. They have the same slope, and this means, because of this +1, this actually means that they don't intersect. And we're going to talk about today more formally that such a solution, such a system has no solutions, because a solution is by definition the point at which two lines cross each other. Okay, so these two lines don't cross each other because they look like this. And so therefore there is no solution. You could go way out to like 1,000,000, x equals 1,000,000, and they'll still look like this. And you could go all the way to a negative 1,000,000. You'll never find a point where they cross because they're parallel. So that's the geometric interpretation, okay? What about perpendicular lines? What are perpendicular lines? Can someone define?
They're two lines that intersect at a 90-degree angle.
Very good. And we like this nice, angle depiction. Now, seniors, I suggest that I actually didn't know this term in high school, orthogonal. It's synonymous to perpendicular for the purposes of the math that you're familiar with now. And later on, maybe in college, you'll learn sort of a more general notion of perpendicularity, and that is called orthogonality. And so just, you definitely don't need to know this for the SAT, but just in case you hear that down the line, okay, that's what that is. It's basically synonymous. It's the same thing as perpendicular for your purposes at this point. So what is so we said that for parallel lines have the same slope. What is the relationship between the slopes of lines that are perpendicular?
Negative reciprocal.
Negative reciprocal, very good. And this is actually, I don't know who said that, but I'm very proud of you because this is not a trivial result. So basically, whoever said that, thanks. So if you have some general line, y equals mx plus b, what your colleague just said is that a line that's perpendicular to this line will have the slope negative 1 over m. In other words, you take the slope that's given, you stick a negative sign on, and then you flip it. That's what the reciprocal means. So negative reciprocal. And the proof, if you want to know why this is true, you actually, if you want to know like why the negative reciprocal slope gives you a perpendicular line, you actually are going to have to wait until you take, I think, some more advanced math. Maybe if you've taken pre-calculus, you've learned the notion of vectors. This can be shown using vectors. This can be shown with linear algebra. So I'm not going to show you why this is true, but this is very important. The SAT people love asking questions about this, okay? So for example, if I have the line y is 2x, what would be the slope of a line perpendicular to this line? And let's see. Anyone, I guess, let's give a chance to, because people are complaining that others are not getting their voices, and let's, Nathan, are you there? Lydia, are you there? No. Tanisha, are you there? Avery. No, okay. I don't know what to do if people, I don't know if people are not answering or just people are not here. Does anyone, I mean, what would be the slope?
Tanisha said she's here.
Oh, she said she's here. I see in the negative. So someone said -2/5. Someone said -1/2. Someone said 2. I wish we could take like a vote. Okay.
-1/5.
-1/5?
I thought it was 2.
You thought it was 2. So
I think it's 2.
The slope would be 2 for a line that is parallel to this line, y = 2x. We want the slope of a line that's, yes, and so Matthew and John is up. So yes, now people are starting to get the right answer. So look, negative reciprocal. So if this is m, if 2 is m, what is -1/m? It's going to be -1/2, which is the same thing as -0.5. Okay, so your slope, so any line with the slope y, like any line of this form, you can set b to be anything. Any line of this form will be perpendicular. Any line of this form will be perpendicular to this line. Make sense? So let's do an example that's very typical of SAT. Draw a line perpendicular to y = 5x plus 2 that passes through the point 0, 1. So what's the slope of this line going to be?
-1/5.
Say that louder.
Negative.
-1/5.
Yes, thank you. So m is -1/5. And so we know that the basic form of this line is y = -1/5 m plus b. And now we have this condition that it passes through this point 0, 1. And this condition, sorry, this is an x, sorry. Okay, does everyone see this mistake that I made? Your equation for a line is y is mx plus b. I confused my mistake, okay? Make sure if you wrote that down, that you correct it. Now, this point here is going to define what b is. So how do we figure out what b is given this point? Anyway.
Because the point is the y-intercept.
Yes, that's very astute of you to say, because you noticed that this point is the y-intercept itself. And therefore, and what do we know that the y-intercept, I mean, in the slope-intercept form, the y-intercept is just given by b. So what is b?
It's unknown, so you have to find it.
No, that's exactly what I'm saying. You don't have to find it.
It's 1.
It's 1. Okay, sorry for the technical. Yes, so many people are saying 1, 1, 1. Yes, it's 1. Now, so b is 1. So the answer to this question would be this. Now, what if I said, draw a line perpendicular to this that passes through not the point 0, 1, but passes through, say, I don't know, 2, 3. Now, what would the answer to? We're gonna have a different line. It's gonna have the same slope, because that's going to be perpendicular, right, to the line that we want. But this b is going to be different. Now how do we find b?
You can plug in the x and the y into the equation to find b.
Yes, exactly. So here is x, here is y, and I'm going to plug it in. So y is 3 is minus 1/5 times 2 plus b. And now you can solve for b. So what does b equal? You just have to do this, right? 3 plus 2/5 is b. And this is like 15/5 plus 2/5, which is 17/5 is b. So it's not a pretty number or anything, but your answer in this case, to answer this question, would be y is negative 1/5 x plus 17/5. Does everyone kind of see how to do this sort of problem?
Yes.
Great.
Yeah.
So the main result is that the slope of a line that is perpendicular to another line is the negative reciprocal of that first line. Okay?
I have a question.
Sure.
I'm wondering why the fraction didn't end up negative.
Why the fraction didn't up? Okay, so thanks for asking. This is great. So this, are you talking about, hey, by the way, can you people see this little cursor of mine?
Yeah.
You see this
Yes.
little
You can see
dot?
it. Yeah.
You see
Yeah.
it? Okay, good.
Yeah.
So I can use it as like a pointer. Okay, so you're talking about this step, right? Is this
Yes.
this is where you're confused? Okay, so I'll just do it again. So this is you were good up to this part. You know, we plugged in the point. Okay, so 3 is minus 1/5 times 2 plus b. How do you solve this equation?
You have to use inverse.
Yeah, so Nishan has said you have to use inverse to make a positive. I don't know, Nishan, what do you mean by that? You have to use inverse to make it a positive.
It's negative, so like you have to use inverse operation because it's negative. So if it was positive, we would have to make it negative because we're taking it to the other side because we want b alone.
Right, so this is just sort of basic algebra. And so if you were to solve, in general, if this were just, this is sort of the thing that you probably did in like 5th or 6th grade. So just to revise, okay, if you have you're trying to find what this is, okay? You want to basically isolate it on one side of the equation. That's what solving an equation is. You isolate a variable on one side of the equation. And so to do that, we're going to add both sides by this, because this, you know, minus 2/5 is sort of trapped on the same side as b. So if we add it to both sides, right, then this and this cancels, right? Minus something plus that same thing gives you 0. And so what is 3 plus 2/5? Now this is just like 4th grade problem, right? Because you learned how to add fractions in probably 4th grade. So obviously, you know, 3 is just 15/5 divided, if you don't believe me, plus 2/5. The reason I did this step is, you know, common denominator. That's how you add fractions. So you should know how to do this. Does that make sense? Does that help?
Yeah, thank you.
Okay, sure. Thanks for asking. It's always, yeah, please, I appreciate you asking. So thanks. Okay, now we're going to talk about systems of equations. So this really has nothing, what we're going to talk about now has nothing to do with like what we were doing earlier. Okay, so this is sort of a new topic. I should have made like a title here, systems of equations. This is a huge field of math. The field that, okay, so there's this entire branch of math called linear algebra. And this is sort of the basic approach. This is sort of the simplest case of linear algebra. Generally, all systems of equations can be written as matrices and vectors, and there are general solutions to n system of equations. So you could have like 100 linear equations and you could solve them. Okay, it's kind of mind-boggling, but this is something that you'll learn. So, but for the SAT, everything is going to be like a 2x2 system. I don't even think they're going to ask 3x3. And we're not going to deal with 3x3. We might a little bit tomorrow. So my plan for tomorrow is to sort of introduce some of you to linear algebra and talk about how you can do these same problems using this more elegant approach. But for today, we're going to use sort of the brute force, old school method, okay? So the first thing that, the first approach I think that is easiest to grasp, and so this is going to be a review for some of you, okay? But I think the easiest way to think about this is as a solution being defined as, that this means defined as these three lines, a solution being defined as an intersection of two lines. So if I plotted these two graphs, and we talked about this yesterday for ages, this is the first graph. Y is x plus 1, and y is 2x plus 3 is somewhere up here, right? So this is 3. It should actually be a bit higher, but anyway. And so they cross somewhere. You can see that these lines are not parallel because the slope is clearly different, and
They're perpendicular.
they're not perpendicular. They're not perpendicular. If they were perpendicular, then you would have one line going off like this, right? Which is not the case. Hello? Okay, I'm not sure if anyone was saying anything. Okay, so this is one approach to, and this is actually kind of how computers will solve systems often. They'll just plot lines and then they'll numerically find this point. They don't, computer can't think, but it can numerically figure out where lines intersect. So graphing is one approach. Another approach would be to substitute one equation into the other. So look what happens if we substitute, I'm going to call this equation 1 and this equation 2. Let's substitute equation 1 into equation 2. So what happens if I put in this expression for y into here?
Probably 2 times x plus 1 plus 3, and then you can use distributive property.
2 times x plus 1. I think you're confusing. I think you're putting in y for x.
Are you not supposed to do that?
No, because look. Okay. So did you see what you said? I don't want to confuse people. You're putting in x plus 1 for x.
Yeah.
You can be putting x plus 1 in for y.
Oh, okay, I see.
Okay, so here, so this is, look, this is y, and this is y. It's a true algebraic statement, so that's why this can be done, okay? Now this is just one equation with one unknown. And therefore it has a solution, and we all know how to do this. How do you solve this equation? This is very trivial.
Subtract x on one side, and then 3 on one side, and get it.
Right, so I can subtract x here, and I could, so if I subtract x on both sides, I have to subtract x on, if I subtract x on one side, I have to subtract x on both sides. And I can also subtract 3 on both sides. So this is, I won't do this every time, okay, what I'm doing right now, but it seems that some of you need a little bit of review. Okay, so I'm doing it. So x minus x is 0, 1 minus 3 is minus 2, 2x minus x is x, and then obviously 3 minus 3 is 0. So what is x? It's right here, x is minus 2. But is this the solution?
No.
What do we need?
You need to substitute the value of x into the equation.
And why do you need to do that?
You've only found the value of x. You still have to find like the actual solution in the solution set.
Exactly. So the solution, we're dealing in 2 dimensions. So if this were a one-dimensional problem that only dealt with x, like in other words, if there were no y, first of all, you wouldn't have a system. But if you're given a one-dimensional problem, then your answer is going to be one number. But this is a 2-dimensional problem. Look, we have an x-axis and a y-axis. So your answer is going to be some point in the 2-dimensional space. And you need 2 numbers to define a point in 2-dimensional space. So we're going to do exactly what you guys suggested, and we're going to put this equation put this point, x is minus 2, into one of these equations. You should, if this is indeed a solution, you better get the same y, no matter which equation you put minus 2 in. So let's see. Let's put minus 2 into equation 1. So this will give y is minus 2 plus 1. See? And what is minus 2 plus 1?
Negative 1.
And now I'm going to put it into 2, and we better get -1. If we didn't get -1, we don't have the right answer. So -2, look, sorry, not -2. 2, I don't know why that, okay. There's an issue with this. 2 times -2 plus 3, what is that?
-1.
Yes, because it's -4 plus 3. So indeed, we got the same. So this is indeed a solution, and you would write the solution as an ordered pair. Okay. So this is the solution. Make sense? So we talked about 2 methods. One was not very satisfying, but it's a graphical sort of interpretation of the problem as lines that intersect. And so the solution would be here roughly. And indeed, the way I drew it was not great, but you can see that this is roughly the point -2, -1. It looks like it's actually on the axis, but it's not. It's somewhere around here, okay? If I had drawn this better. Okay, so we talked about a graphical solution. We talked about using the method of substitution. And the method of substitution is really convenient, and basically any method works. What you're really going for is eliminating one of the variables, right? So what did we do? We had 2 variables and 2 equations, and by substituting equation 1 into equation 2, we eliminated y. And then we had this old school, 1 equation, 1 unknown sort of problem that we've done since 5th or 6th grade. Any questions?
No.
No. Okay, let's do this one. Let's do this by substitution as well, okay, just so we have a bit more practice. Okay, so I'm going to go faster, okay, now that we sort of understand how this is going. So I'm going to substitute 2 into 1. You can do it the other way. It doesn't matter. In fact, here substituting 1 into 2 is exactly identical to substituting 2 into 1, okay, but I'll talk through it as if I'm substituting 2 into 1. So I'm going to put this y in for here. So x minus 3 is going to be used as y. And how do we solve this equation? Old school, I mean, you subtract. I like to put, it doesn't matter where you bring the x, but I'll subtract x on both sides, and I'll subtract 1 on both sides. So so this side will just have x's, and this side will just have numbers. That's the intention. So x minus x is 0. Minus 3 minus 1 is -4. 5x minus x is 4x. 1 minus 1 is 0. So minus 4 is -4x. So what is the solution to this?
X equals -1.
-1.
Yes, x is -1. And now how do we find the corresponding y value of the solution? You can put this in.
Plug it into one of the
Exactly.
solutions.
So I think this one is a nice equation to plug in the found value, because it's kind of simple. So y is -1 minus 3, y is -4. Okay, so your solution would be, -1, -4. Make sense? Great. Let me know if you have any questions. I'm just going to kind of blaze through these, and I assume everyone is going to, if you don't say anything, I'm assuming that everyone is following. Okay?
Okay.
So here, this is a nice question, okay? Because instead of substituting, you can perfectly well substitute, you can perfectly well graph these, but there's actually an easier approach. Does anyone know what that approach would be?
Elimination.
Elimination, yes. And so what is elimination? So technically all of these approaches are elimination, right? What we did here is we eliminated one of the variables by substitution. So technically we're always doing elimination, but what is going on here? Like, what is the sort of,
Like here, like since there's a negative and a positive, you can like eliminate those and then create like an easier way to solve the problem.
So when you have like a negative sign here and a positive sign, so tell me, maybe one of the 9th graders, what is this? What is the answer here?
0.
Yay.
Yep.
So what's this?
0?
Yes, why are you hesitating? It's yes, anything. In fact, this is the definition of 0. This is a nice way to define 0, and also a nice way to define equality. Yeah, anything, minus anything plus positive that thing is 0. So that's exactly the reasoning we're using here. So if we just add these two equations, you obviously add both sides of the equation. So what is y plus y?
Y squared.
Oh,
Plus y is 2y.
okay. This is here. Let's clarify. Y plus y.
2y.
Yeah.
Y times y is y
I
squared.
don't know who said y squared, and there's no shame in getting this wrong because I used to get this. I remember like the days when this was confusing me. Y times y is y squared. Y plus y is 2y. See,
Okay.
y squared by definition is y times y. Anything squared is that thing multiplied by itself. Okay. Anything that's multiplied by 2 is that thing added to itself. Make sense? So don't make this mistake.
Yes.
This will mess you up. Okay. So yes, this side is 2y. What is we said that x, minus x plus x is 0. So 0. What is 10 minus 4?
6.
Okay. What is y?
6. Oh, yeah. 3.
Yes, 6 divided by 2 is 3. And now how do we find the x value? You can just put it in
Plug 3, yeah.
either one, and I'll plug it into this second equation, okay, because it's kind of simple. 3 minus 4. So your solution, sorry. I screwed up here. We're trying to find the x value. So we have the y value, and we need this x value.
Oh, yeah, okay.
Right, sorry, I made the mistake I was about to warn you guys against making. Okay, so I'm going to put in 3 for y. So 3 is x minus 4. And now what is x? 3 plus 7. 3 plus 4, which is 7.
Is 7.
So your solution is 7, 3. Does this make sense? I'm going kind of fast. Yes, and Alexis got it right. Like a long time ago, far before I had the answer. Okay, great. Does this make sense to everyone?
Yeah.
Yes.
So there, we've talked about graphing and substitution, and now what they call elimination, but it's really just like addition. These are 3 methods, and tomorrow we're going to talk about matrices a little bit. Okay, not like super in depth, but I'm going to introduce this idea to you. And this is a very powerful, this approach is sort of, all these approaches are very brute force. You can kind of, if the numbers are good, they sort of work. This approach always works. And this is what your computer actually does. This is what your calculator does. And it's very powerful. It's a bit more abstract, but once you get your mind around it, you'll feel smart. Oh, and
What
there's
is that called?
Sorry?
What is that? I can't read it.
Yeah, sorry.
Matrices.
The theory of matrices.
Okay.
So like the matrix.
Yep, we're going to talk about this tomorrow. So people are already asking like if there's class tomorrow. Yes, I should have clarified this at the beginning. The reading class is Monday, Wednesday. The math class is Monday, Tuesday, Wednesday, Thursday. So we meet Monday through Thursday. The reading is only Monday, Wednesday. So we will meet tomorrow.
At the same time?
At the same time, 10 to 11. Yeah.
Okay.
This problem would be like substituting inside, right?
This one that I have up here?
Yeah.
Yes. Yeah, so you can, okay, so thanks for the suggestion. Let's do this by substitution. Okay, so I'm going to substitute. Which one do you want to substitute? Do you want to substitute 1 into 2 or 2 into 1?
1 into 2.
Okay, so great. So writing 2 in terms of 1, in other words, I would have, do you agree? Does everyone agree?
Yes.
See, I'm going kind of fast. I hope that this is not too bad. Let me know if I need to slow down, okay? Don't be shy. So now how do we solve this for y?
Add y on that side, and then 2y is equal to 6, and then y is 3.
Great. And then how do we find x?
Plug 3 in for y.
Yes.
In the second equation.
So let's plug it into, well, I'm going to put it into the first because it's already in terms of x. So x is minus 3, which is what we just found. Minus 3 plus 7, which is 4. So our solution is 4, 3. Yeah, go ahead. Someone had a question? No. Okay, does this make sense?
Yes.
Okay, we're just chugging through these problems and you're gonna get more practice on the homework. Just, take notes. If you're not following what's going on, I'm sure it'll click very soon, okay? I do hope the pace is okay, okay? Let's do this. Okay, I'm gonna do maybe substitution. I'll substitute 2 into 1. So I'm gonna put this 3x minus 1 in here. Okay, so it's gonna be 3x minus 1 minus 7 is 2x. How do I solve this for x?
Subtract 2x or subtract 3x on the other side and then solve for it.
Okay, so you're saying this will be minus x and this will be minus 8. So x is 8, and then y is, I'll substitute this into 2. 3 times 8 minus 1 is 24 minus 1, which is 23. Okay, so the people who are complaining that like only a few people are participating, I can't really do anything. I don't want to tell people to not participate because I do appreciate those who are. But if you feel that you're not getting your voice in, just be brave. I don't care if you get it right. I can't even see your face. Okay, I will never make fun of anyone. Like that's not the spirit of this class. In fact, I like it when people make mistakes because I think of how I was. I was the worst math student. Okay, so please chime in. Okay, does this make sense? So your solution is 8, 23.
Yes.
Yes.
Okay. So did someone say no?
No.
I didn't hear a no.
Okay, I thought I heard someone say no, which is fine. I'd rather hear no than yes sometimes. Okay. How do we do this?
Jesus. Substitute?
Yeah, it doesn't matter which way you can do it.
Yeah.
You can either go for the y part or the x part, but the y is easier.
Mm-hmm.
The y is easier, so how would you suggest?
10y is equal to
yeah.
10y
you want-
is yeah. You can say.
No, you could go. It's fine.
Alright, so it would be 10y is equal to
Wait, buddy.
Any other thoughts?
I think you can move the 5x or the 10x or the 10y.
You can
The other
move
side.
you can move the 5x to the are you saying this?
What?
I'm just doing what you're telling me to do. Any other ideas? Does anyone have a clear approach? Okay, sorry, my internet cut out for a second, so I don't know what. Can everyone hear me?
Yes.
Okay, sorry. I got very scared. I was like,
Yes.
okay, great. You can hear me. Okay. How about we multiply the top and bottom, just the bottom by 10. I'm going to multiply this entire bottom expression by 10, the bottom equation by 10. And you'll see why, because I'd like to use elimination. I'd like to actually now that I have this, does everyone see what I just did?
Yes.
Okay, so 10 times y is 10y, 10 times 10x is 100x, 10 times minus 50 is minus 500. Now, this is kind of nice because now I can just subtract this entire bottom equation from the top equation, thereby eliminating the y's in the problem. So 10y minus 10y is 0. 5x minus 100x is, just do the math, minus 95x. And now this is kind of tricky because you have two minus signs. Minus 500 is 500. Make sense? And so now you can solve this dirty, it's kind of an ugly expression.
I have a question.
Go ahead.
So why is it how is it minus 500 and then you got plus 500?
That's a great question. So if I
minus
had,
times minus.
really what I'm doing is, there is no number here, right? So this is plus 0. So just dealing with this part of the problem. I have 0, and then look at this minus sign. Minus 500. How do you do this? It's 0. This is, what is minus minus? That's just plus. So this is just 0 plus 500, which is just 500. And that's how I got this.
Okay, thank you.
Clear? Okay, great. So now you can solve this for x, and this is just a bit of math. Minus 500 divided by minus 95, and you can do this. I'm actually not going to do this for the sake of time. And then you obviously you just take this value and you put it in for x in any of these equations, and you can get y. I'm not going to do this just because I'd like to get through some more actual meaningful problems. So what about this problem? Oops. Okay, what
5x is equal to 4x. No, that one.
5x.
Wouldn't it just be,
Mine, that wouldn't work.
yeah, it'd just be 0, so no solution.
It would just be 0, and so whoever said yes, that's very good. So this is one of those nice problems that we can say by inspection, just by looking at it. If you just put in x equals 0 and y equals 0, both of these equations are true because 0 is 5 times 0, surely, because 5 times 0 is 0, and similarly 0 is 4 times 0. So 0 comma 0 is the correct solution. And this is the beautiful thing about linear equations, because generally, two lines that are not perpendicular, two lines that are not parallel will cross at one point, right?
Yeah.
This is one of the things that Euclid said in the Elements, like thousands of years ago. And if you found one point at which they cross, that is the only point that they'll cross, given that these lines are not parallel. So now that we've found, this is sort of like theorem of uniqueness. Sometimes you'll hear this thing, like theorem of uniqueness. In other words, lines that are not parallel cross at one point, and only one point. So therefore, now that we've found one solution, we know that it's the only solution. Does that make sense? Does the logic make sense?
Yes.
Great. So that's good. And if you wanted to do this by graphing, what does 5x look like? What does y equals 5x look like? It's like the parent function, but it's steeper, right? This is what we talked about yesterday for ages, right? And what does y equals 4x look like? It's like the parent function, but just a bit less steeper than 5x. And where do they cross?
Would we be able to put no solution?
Well, there is a solution. So
Okay.
yeah, so this is not so clear. Clearly this point satisfies these equations as I showed here. So yes, there is a solution. Okay, what are people chatting about? Yes, the solution is okay, Alexis, very good. And yeah, other people are saying, yeah, the solution is the origin. Does this make sense graphically and algebraically? Yes?
She.
Okay,
Yeah.
thanks. How about this? How is this any different from this?
It's still 0.
There's a decimal.
Yeah, there's a decimal. So the previous problem was this. 4x. Now I just changed one number. Is this any different?
No.
No, and what is the solution?
0.
Yeah, when you say the solution is 0, you need to say actually, 0 is not the solution. 0 comma 0.
0. Origin.
Yeah, the origin, exactly. Yeah. And graphically, what does this look like? Are these lines parallel?
No, they're perpendicular.
Oh, no.
They intercept.
Yeah, they're intercept, sorry.
Okay, so these are three different things. So they're not parallel, Monty says in the chat. They're definitely not perpendicular. If they were perpendicular, one of the slopes would be the opposite reciprocal of, the negative reciprocal of the other, which is not the case. 5 is not the negative reciprocal of 4.999. So graphically, what's going on? Here is 5x. Okay, I'm going to try to do this kind of carefully. 5x. Can everyone see this line? Okay.
Yes.
4.9999x is just ever so slightly less steep than 5x. So it's almost the same line. But you see how it's just, it like just grazes, okay? It just grazes, they just intersect at 0. So they're almost the same line. But there's still one solution. Like in other words, the distance between these two lines diminishes and becomes so small just at this point. And then they cross and then they slowly start leaving each other again. Does that make sense?
Yeah.
So there's still, they're almost the same line that there's only one solution. And it's that solution is identical to this. Okay? Now, why are we talking about things almost being the same line? Well, let's look at this. What if you have a system of two equations, but those two equations are equal?
Infinite solutions.
What is that you said?
Same line.
Infinite solutions.
Infinite solutions. What is infinite? Also, okay, everyone is saying all solutions different. What does that even mean?
Any number, it doesn't matter what it is. It can be from negative infinity to positive infinity. It'll all be true.
But which number are you talking about? Any number.
Just any number in the number.
Okay, I'll do what you told me. Is this a solution?
Oh, well, no, they have to be the same number.
Okay. Is this a solution? What's wrong with what you're saying? They're the same line. Okay, so you all are saying the same thing.
Any solution that suits one line will suit the other line.
Hey, who said that?
Aruhi.
Yay. Okay, not to be too, does that make sense? Okay, so this is clearly not a solution. This is not a solution. It's not just, you can't just pick any random numbers. This is not just like a free-for-all, right? There's still some specificity to this problem. What is true is that if you put like, say x is 1, then from this top equation, y is 5. Clearly this solution also works for this solution. And you could make an infinite number of cases, like x is 2, y is 10, x is 3, y is 15. So on and so you can go on for both of, this point and this point satisfy both equations. This point and this point satisfy both equations. So when we say all real numbers are all solutions, we're saying that there are an infinite number of solutions. Those aren't that's not the entire plane of numbers in 2D. They're actually very specific numbers, but there are an infinite number of those numbers. Okay, so someone has raised her hand. Go ahead. I didn't know you could do that in here. Go ahead. Okay, I don't know if your hand is raised anymore. Just you don't have to raise your hand. I'm not going to be able to keep track of. Just shout it out, okay? Does this make sense? So graphically, what's going on? Remember in the last example, we had those two lines that are just grazing each other? Well, now you have two of the exact same lines. And they're both lying on top of each other. So any point on this line is a solution to the system of equations. All of these points. But like the points that someone else suggested, like any number, like 1, 10, that's not on this line. So it's not a solution to the system. 1, 1, that's not on, that's way down here. That's not on this line. It has to, the solutions have to be on this line. But there are an infinite number of those solutions. And so what you would say is, all real numbers. Make sense?
Yeah.
Great.
Yes.
So, kind of in conclusion, okay, let's just do one more example. So we have found that, so far, we found that if two lines are just generally, not parallel, They can be perpendicular, but generally not parallel, that they'll cross at one point. So you have one solution here. We've also seen a case, like in this example, where the two lines are overlapping. And here, how many solutions do you have?
One.
When they're, look.
All real solutions.
So how many is that? There's a nice infinite, right? So in Alexa said in the chat, an infinite, yes. So the number is actually uncountable. There are an infinite number of solutions. And now we're going to see, I'm going to skip this example because that's not. Now we're going to see a case when there are no solutions. And this is how we began the lecture. So these lines, you can graph these. 2x looks like this, roughly. And 2x plus 1 is the same line, just shifted up 1 unit.
They'll never touch ever.
So they never touch. Yes, they're parallel.
Parallel.
And so we know from, geometrically that there is no solution because parallel lines never cross. But how would you show this algebraically? If you can manipulate these equations in such a way to come out with a false statement, then you know that there is no solution. So if you can make these equations clearly say something that's mathematically wrong, then you know that these equations are not compatible, so to speak, with each other. They share no common points. And how would you do this? One, there are many ways to do this. One way you could do this. I don't know what the deal is with this chat box. Okay, one way you could do this is just subtract the equation. So I'm going to subtract the bottom equation from the top. Y minus y is 0. 2x minus 2x is 0. And 1 minus 0 is 1. So I am now getting the statement 0 is 1. Is this true?
No.
No. You could literally, I remember the first day I learned like 1 plus 1 is 2. I remember I was like 3 or 4. That's one of my earliest memories. You could ask a preschooler this, and they would say no. So this is sort of, whenever you come out with these false statements, you know that your system has no solution. You can go searching the entire universe for x's and y's that would fit this, this system of equations, and you will never find a single x or y that satisfies this equation. And if you can just try, suppose x is 1, then y is 1/2. That's according to the bottom equation. Now I'm going to put the same x and y into the top equation. So y is 2 times 1 plus 1. That's 3. So the top equation for x is 1 gives you y is 3. The bottom equation for x is 1 gives you a totally different y. Make sense? I myself feeding back somewhere.
Yeah.
Okay, so I'm going to now send you the attendance quiz. And I know we ran a few minutes over, so thanks for sticking around. Does anyone have any last minute questions before the quiz?
I have a question, but it's regarding the homework, not the.
It's regarding the homework. Okay.
Me as well for the homework.
Okay, so I just sent you the quiz. It's on. Does everyone see it? It's on the group chat.
Yes.
Okay, great. So go ahead and take that. Okay, and if you have a question about the homework, go ahead. Hello?
Hey, Chirag, this is Gabe. I'd like
Hi,
to
Gabe.
talk to you after this is over.
Sure. So someone had a question.